Hello, good people. This video has to do with domain and range. Domain and range are things or ideas that you started back in Algebra 1, maybe even before Algebra 1. The idea of domain and range tells us where the function that we're talking about actually exists. And so when we talk about domain, I need you to remember that domain is always talking about x values, right? So on what x values does the graph exist? And then range is the y values. So on what y values does the graph exist? Now, when we're given a graph, I tell students to think about two directions because we know that range is how far low to how far high, and domain is how far left to how far right the graph goes. And so x's, if you look at the x-axis, x's go left to right, correct? So I want to see what's the biggest window where this graph exists. The graph has to exist, but what's the smallest x value that it exists? What's the largest x value? And then the same thing for the range, right? We're looking for the y values that the graph exists. So what's the smallest y value that the graph exists? What's the highest y value that the graph exists? So when I'm looking at this graph, we know that the graph goes up forever, but we also notice that it's angling out. And so when I'm looking at the graph, not only is it going up, but it's going out forever. And so that means that if I'm going to use um, interval notation, I'm going to say on x's that are a part of from negative infinity to positive infinity. That's where the domain is because that's where the x values of the graph exist. The graph exists everywhere. And so some people even say this, x is a part of all real numbers, meaning any x value that you can think of, the graph exists there. I know that because I'm looking at the graph, and the graph, you can pick this x value, and the graph is there. You can pick this x value, and the graph is there. Because the graph keeps going out, any x value that you pick will hit the graph on that location. Now, the y values, well, they're a little bit different, right? The y values is how far low to how far high, smaller to bigger, always smaller to bigger, just like left to right was smaller to bigger. So now we're talking about y values. And in this example, y values that are a part of. Well, let's see, what's the lowest that it goes? Well, the lowest that it goes is negative 2.25, that minimum point that we talked about in the other video, negative 2.25. And then what's the highest it goes? Well, it keeps going up forever. So that goes to infinity. I apologize for my pen. I will try to write a little bit more carefully. And so we say that by the way, is there a point at negative 2.25? Does the graph exist at negative 2.25? Because I see that it does. There's a lowest point. So therefore, I shouldn't put a parentheses. I should put a bracket. The bracket means it includes that value. A parentheses means it doesn't include that value. And some people say, well, how can it not include infinity? Well, infinity really isn't a location. It's not really a number. It's just telling us that it goes up forever without stopping, right? So when I'm looking at this, this is saying y values from negative 2.25 all the way up forever. That's where the graph exists. So I can pick any y value in that window, and I'm guaranteed to see or touch or intersect the graph at that y value. That's all the domain and range is, right? The x values and the y values where the graph exists, where the function exists. But because we're looking at a graph, I think of it in terms of left, right, and then down, up. Always smaller number first, so that we can go from small to big. But in a nutshell, I think you remember what domain is. If you don't, I hope that helps. We'll do another example here in the we do after I do the I do.